So my name's Rosie Sheldon. Welcome to this webinar. I work for TSG Training and I'll be presenting the webinar today, and I trust you can all hear me. Just a bit of housekeeping. During the presentation, you'll all be on mute, and if you have any questions, please put them in the chat box for the Q&A session at the end. I'll be talking today about the ISTQB AI testing course, and if you want to know more, please do contact us. The next courses are on the 20th of January and the 22nd of April. And this webinar is being recorded, and it's going to go straight on our website, shown here, tsg-training.co.uk. So first, I'm going to introduce a bit about AI before talking about how the course fits in the context of the ISTQB family. I'm not going to go through the syllabus in detail, but we'll pull out some interesting bits to give you a taster. And today, my focus is on AI-specific quality characteristics. When first released by OpenAI, the new artificial intelligence tool ChatGPT went viral. I'm sure you've had a go. Or maybe you've investigated a tool that allows you to turn any prompt into AI-generated art. AI's come of age. It's all around us. And what is meant by AI is changing. We don't even necessarily realize that there's AI in the products we use. So what is AI? Well, it's the science and engineering that makes intelligent machines. Artificial intelligence is software that thinks, in inverted commas, intelligently. AI is the broad field of developing machines that can replicate human behavior. And that includes tasks related to perceiving, reasoning, learning, problem solving. And it's huge. Typically, AI models are trained using enormous amounts of information. AI can then process the new data and draw unique, intelligent conclusions based on that presented information. If you were in Berlin back in 2019, you may have travelled on one of these small yellow autonomous buses that had just been deployed. The city was the first to introduce self-driving buses in Germany. They use AI to make immediate decisions using data from the recent past. They use sensors to identify steep roads, traffic signals, people crossing the streets, and the vehicle then uses this information to make better driving decisions and avoid accidents. Social media platforms like Facebook, X, Instagram rely heavily on artificial intelligence for a variety of tasks. And these social media platforms use AI to personalize what you see on your feeds. And the model identifies users' interests and recommends similar content to keep us engaged. And then there's chatbots. And getting queries answered directly from a customer representative can be very time-consuming. And that's where artificial intelligence comes in. Computer scientists train chatbots to impersonate the conversation style of customer representatives using natural language processing. And it trains the chatbots to respond to various questions. Search algorithms ensure that the top results have the answers to our queries. The search companies usually include some type of quality control algorithm to recognize high quality content. And it then provides a list of search results that best answer the query and offer the best user experience for us. And as the use cases for artificial intelligence grow, it's inevitable that we discover more ways that it can improve our lives. And Forbes expects that the global AI software market will reach 22.6 billion by 2025. So AI is here, AI needs testing, and it's a specialist area, hence the course. And it fits into the wider family of ISTQB courses as follows. So here's the ISTQB roadmap with the Agile core and specialist streams shown. So initially, The focus after the foundation level certified tester course was on the original core advanced level courses, the test manager and test analyst and the technical test analyst. But then the agile stream with the newly available agile technical tester and the specialist stream were developed. And many testers have sat some of these courses, particularly the test automation engineer and the mobile application tester. And the AI testing course is part of this specialist stream. It's a specialist area, giving knowledge to technical testers and test engineers, typically using agile methodologies. And as you can see from the arrows, all the certifications require the foundation certified tester as a prerequisite. And the courses in orange are other courses provided by TSG Training. So the material for the AI testing course is taught over 4 days, using slides and practical exercises and discussions and practice multiple choice questions. And this is to support delegates as they prepare for the 1 hour 40 multiple choice question exam that's usually sat about a week after the course. And these are the topics covered in the course. And there are learning objectives against each chapter. And there's also hands-on learning objectives covering most topics, the dark blue ones. I'll just let you look at those headings. So AI is the broad field of developing machines that can then replicate human behavior, including tasks around perceiving and reasoning and learning and problem solving. And AI can be implemented using a wide range of technologies like fuzzy logic and reasoning techniques and machine learning. And this course focuses on machine learning. Machine learning was a major breakthrough in achieving AI, and there are numerous machine learning algorithms, and some are shown here. And these detect patterns in large data sets. As an example, they learn to make predictions by processing data rather than by receiving explicit programming instructions. And in the course, we explore these during practical exercises using Weka, which is a collection of free machine learning and data analysis software tools. And deep learning is an advanced branch of machine learning that uses neural networks, inspired by the way that neurons interact in the human brain. And the neural network ingests the data and it processes it through multiple iterations that learn increasingly complex features of the data, and it makes increasingly sophisticated predictions. These deep neural networks are called deep because they are many, many hidden layers, and this has resulted in great leaps forward in AI in recent times, with learning now being a reality. I'm now going to compare how conventional systems are developed with the machine learning-based development process. Weka stands for Wakato's Environment for Knowledge Analysis, and it's an open source, easily available tool, spelt W-E-K-A. I'm going to start with developing conventional systems, and with some form of requirements, user stories, functional spec, technical spec, and requirements are agreed with the customer, and the software developer then designs and implements the solution in code, which is tested. And this code is then deployed to the target system. And with conventional systems, it's relatively easy for us to understand how the system transforms inputs into outputs. But for machine learning-based development process, you still start with requirements, but let's think of these more as objectives. And then at a high level, the data scientist gathers and prepares lots of training data and selects the right machine learning algorithm. And next, the machine learning algorithm is trained by feeding large volumes of training data into it to create the machine learning model. And this model is predicting the right response given the data it's been trained on. So the training data is crucial. And it still needs careful evaluating and testing before it's deployed to the target system. It's important to appreciate that the deployed machine learning model code isn't written by the developer. That's generated by the machine learning algorithm code. And this process here from the slides can be covered in more on the next slide. But this is specifically around machine learning rather than other AI technologies. So this was to show that developing a machine learning system is quite different to developing conventional systems. In an AI-based system using machine learning, the training data used is central to the development process. And once live, the model can respond to inputs and make reasonable predictions based on this training. So this is the machine learning workflow from the syllabus. And as you can see, AI introduces special test levels for machine learning testing. And the course steps through this workflow in detail, and it uses practical exercises to support the theory, as I said, using Weka. And delegates download a variety of free open source tools and resources to do the practicals. And I'd like to talk now more about the prepare and test data box. So here's a slide of some labeled training data. And this is the data that's going to be used to train the algorithm that builds the model. But the resultant model is going to be biased and inaccurate because it's been trained on poor quality data. I've kept it simple. This is training data for a classification system that's identifying cats and dogs. And you can see that the training data has been sourced. Covers cats and dogs lying down, sitting up, on their own, and with the other. Ideally, as many scenarios as possible should be covered. And you can see you've got the training data that's got the labels, cat and dog, but sometimes mistakes happen in the labeling itself. Was the image mislabeled as the labeler was given poor instructions or limited training? Or was it wrongly labeled as they were working under difficult conditions, or they just made a mistake? Either way, here in the bottom right corner, it's a cow, not a dog. So sometimes data is mislabeled, but is the data varied enough? I mean, the animals are in different postures, but look, the dogs are consistently white and the cats are black. So we've now got unlabeled, novel production data, and this is processed, and the model has to predict the classification. And here, the cow's been incorrectly identified as a dog as a result of the mislabeling of the cow in the training data. And this mislabeling has reduced the accuracy of the model. Here, the dog's being correctly identified by the model as a dog, but this white cat has been identified as a dog due to incomplete training data being used for the training. Because, as I said, all the examples of cats in the training data were black and all the dogs were white. So this cat has been labelled dog. And incomplete data used in training will result in a biased model. And in the real world, it could be a model that's gender biased or ethnicity biased as examples. So this training data was prepared and tested before being used for training the model. So this is where the problem lies, where the poor data quality was missed. And as you can see, there's a variety of quality issues that can result in a poor model. The quality of the data is important. It's vital due to its impact on the machine learning model. And the model might have reduced accuracy due to the training data, or it might be biased, or it might be compromised. The previous slides, I showed you issues arising from an inaccurate and biased model, and that resulted from mislabeled data and incomplete data. I love black cats. My old cat was black, so I'm biased towards photos of black cats. It's what I like, it's what I'm used to. So my photo selection is biased. So data is vital. The quality of the data has to be considered. So, in summary, AI is here. Come and learn more about it. I went through a bit about how AI and machine learning systems are different, and that's why there's a specialist course now in the ISTQB certification scheme. The syllabus and the learning objectives and the course content are available on the TSG website, and the syllabus is also on the ISTQB website. I then highlighted some interesting angles of AI to give you a taster of what's covered, and I hope this has whetted your appetite, and I look forward to seeing you on a course at TSG training. So thank you for joining me here today.